The final section in our current unit on basic derivative rules, section 2.4, is about this rule called the chain rule. The chain rule. And what this rule is all about is this rule lets us find derivatives of compositions of functions. This lets us find derivatives of compositions of functions, one function inside another function. The chain rule lets us find derivatives of compositions of functions. What happens when we put one function inside another? For example, y equals the sine of 2x. Or for example, f of x equals x squared plus 3x to the fourth. Or g of x equals the square root of x. Those are all types of problems that we couldn't really have dealt with before, but this new rule I'm about to show you, the chain rule, will let us deal with things like this. Before, I could have dealt with the derivative of sine x, but not the sine of anything more complicated. This one, well, actually, I could have dealt with this one before, but it would have been a pain. I would have had to write this out 4 times, FOIL, take the derivative. That's going to be a pain. But in general, before I could have dealt with just x to the fourth. Now I want to deal with something more complicated to the fourth. And my g of x, I wrote that wrong. I really wanted g of x to be the square root of x minus 2. I could have handled g of x equals the square root of x, but I couldn't have handled g of x equals the square root of x minus 2. Here's what our chain rule says. It says if I want to do the derivative of f of g of x, this is going to equal f prime of g of x times g prime of x. Take a moment and copy that down. What this rule says is if I want to do the derivative of f of g of x, some function inside some other function, I'll take the derivative of my outside function, leaving the inside part inside there. And then I'm going to multiply it by the derivative of the thing that's inside. Let me try to explain this in a different way. Let's say I have y equals the sine of something more complicated than just x, the sine of something. According to my chain rule, the derivative of this would be take the derivative of the outside function, leaving everything inside there, and then we'll multiply by the derivative of the inside. So, what's the derivative of the sine of something? It's the cosine of something. And my chain rule says that after I do that, I should multiply my answer by the derivative of, well, whatever that thing inside is. I want to find the derivative of the sine of something. According to my chain rule, I'm going to get the cosine of something, because cosine is the derivative of sine, and then I'll multiply that answer by the derivative of the thing that's inside, my cosine. If I want to do y equals something squared, my chain rule says I should take care of that outside function. What's the derivative of a square? Well, 2 times the thing that was inside there. To the first. No, you don't have to say that. Times the derivative of the thing inside. I'm taking the derivative of my outside function, which in this case is the square, 2 times the thing inside, and then I'm going to multiply by the derivative of the thing inside. Wow, I don't know why I have two y equals over there. Sorry about that. Y equals something squared. Y prime equals 2 times that thing of the first times the derivative of the thing inside. Y equals the square root of something. I'm going to pause the video, and I want to see if you can write out the derivative of this in a similar way that I wrote out the derivative of the sine of something and something squared. First of all, this is like saying something to the 1/2. So y prime is going to equal 1/2 times that thing to the negative 1/2, and by the chain rule, times the derivative of that thing inside. I guess I could clean this up if I wanted to. 1 over 2 root that thing times the derivative of that thing. Let me start giving you some actual examples. The first one we're going to look at is h of x, which equals x squared plus 1 cubed. And I want to find the derivative of this. H of x equals x squared plus 1 cubed. This is like the problem h of x equals something cubed. My chain rule says the derivative is going to be, okay, take the derivative of a cube, 3 times that thing squared, times the derivative of the thing that was inside. In this case, it's going to look like this. H prime of x equals, the derivative of my cube is 3 times, leave everything inside there, x squared plus 1 to the second. I just took care of my cube. But the chain rule says when you're done with that, you need to multiply by the derivative of the thing inside. The derivative of x squared plus 1 is 2x, so I'm going to get that. Let's clean this up, and we've got h prime of x equals 6x times x squared plus 1 squared. And we've found our first derivative using the chain rule. F of x equals 3x minus 2x squared to the 5th. I'm going to make the video pause, and I want to see if you can go use the chain rule to find the derivative of this thing. I'm going to start on the outside, and I'm going to take the derivative of that 5th power. I'm going to get f prime of x equals 5 times, leave everything inside there, 3x minus 2x squared to the 4th. And then I need to multiply by the derivative of the thing inside, so I'm going to multiply by 3 minus 4x. And I think I'm just going to leave it like that. Were you able to get that for your derivative? Well, let's try a couple more. I think it's probably time for me to go to a new page. Oops. Okay, so let's take a look at f of x equals the cube root of x squared minus 1 squared. F of x equals the cube root of x squared minus 1 squared, which can be rewritten as x squared minus 1 to the 2/3. I want to see if you can find the derivative. Again, the video is going to pause, see what you can do. So f prime of x is going to equal, I got to first take care of the 2/3 power, the thing on the outside. 2/3 times, leave everything inside there, x squared minus 1 to the 2/3 minus 1 gives me negative 1/3. And by the chain rule, I now need to multiply by the derivative of the thing inside, so I'm going to multiply by 2x. I'm going to get f prime of x equals 4x over 3 times x squared minus 1 to the 1/3, or you could say the cube root of x squared minus 1. How did that one go? Were you able to get that? Let's try this one. G of t equals negative 7 over 2t minus 3 squared. Negative 7 over 2t minus 3 squared. I'm going to start by rewriting this as negative 7 times 2t minus 3 to the negative 2. When I go to find the derivative, I'm going to use my constant multiplier rule that says let's just leave the negative 7 out front, and then I'm going to multiply that by the derivative of this piece. That's going to require the chain rule. Again, the video is going to pause, see what you can do. Okay, I'm going to pull down the power, negative 2 times 2t minus 3. I'm going to subtract 1 from the power, so my new power is negative 3. And then I need to multiply by the derivative of the thing that was inside. I'm going to multiply it by 2. Cleaning this up a little bit, g prime of t is going to equal 14 times 2. That looks like 28 over 2t minus 3 cubed. And that's my derivative. Let's do some trig problems. Y equals the sine of 4x. Y equals the sine of 4x. Chain rule problem, because it's not just the sine of x, it's the sine of something a little more complicated. Chain rule says I'm going to take the derivative of the outside part and leave everything inside there. So I'm going to say the cosine of 4x. Then I need to multiply this by what? Multiply by the derivative of the thing inside. You're going to multiply by 4. Your final answer, y prime equals 4 cosine 4x. How about this one? Y equals the tangent of 2x squared minus 1. You take a moment and try this one, and I'll make the video pause. Y prime is going to equal the derivative of the tangent is secant squared of 2x squared minus 1, derivative of tangent is secant squared, times the derivative of the thing inside. Derivative of that thing looks like 4x minus 0. And now I'm just going to rewrite this as 4x times the secant squared of 2x squared minus 1. And it really should be written like this so there's no confusion that the 4x is not like inside your secant squared or anything like that. Did you get that one? What about this? Y equals the cosine squared of x. Y equals the cosine squared of x. The first thing that we need to realize with this is cosine squared x, that's really a shortcut way of writing this problem. Cosine squared x is really cosine x in parentheses squared. It's just a shortcut way of writing it. Now, if I want to find the derivative of this, what am I going to have to deal with first? The square or the cosine? We start on the outside and we work our way in. I think my outermost function is that square. So I'm going to start with that, and I'm going to get 2 cosine x to the first. Then we're going to go and we're going to multiply by the derivative of the cosine of x, and I'm going to get a negative sine x out of that. My derivative is negative 2 sine x cosine x. What I do need you to realize is this problem is very different than y equals the cosine of x squared. If you wrote this problem, it implies that the x squared is inside the cosine. That derivative would have a cosine on the outside first that I deal with. I'd get a negative sine x squared by the chain rule times 2x. Very different. Cosine squared x means cosine x in parentheses squared. And then we work our way in. I have one last chain rule problem to show you for right now, just for this video. Y equals the sine of 3x, that thing raised to the 7th. Y equals the sine of 3x, that thing to the 7th, sine to the 7th of 3x. And I should probably start by writing it in the better form. This is like saying sine 3x. That entire thing raised to the 7th power. Make sure you have that extra layer of parentheses. Without that, you'd probably be showing that it's just the 3x raised to the 7th, which is not the case. I'm going to start on the outside. On the outside, I have this 7. The derivative of a 7th power is 7 times, leave everything inside there, sine 3x, that whole thing to the 6th power, times. I now need to do the derivative of sine 3x. But it's not just sine x, it's sine 3x. It's something more complicated than just a single sine. I need to use my chain rule on this thing. As far as sine 3x goes, there are two parts to this. The outside part is the sine. Inside that I have a 3x. Chain rule says derivative of sine 3x should be cosine 3x. And then I need to multiply by the derivative of the part that was inside that, so times 3. This problem was a 3-part chain rule problem. On the outside, I had a 7th power, which I dealt with first. That's what I'm doing over here. Inside that, I had a sine, which I'm dealing with over here. And inside that, I had a 3 times problem. Cleaning this up, we're going to say 21 sine 3x to the 6th cosine 3x.